Today, we're going to be talking about what I would consider kind of an undiscovered gem in Jump, and it's called the Process History Explorer. As we talk about the analytic workflow of getting data into Jump and then doing things with Jump and uh, sharing the results of that analysis or those insights. The Process History Explorer really kind of fits into this data exploration point. But of course, there are lots of other things we can do in Jump. But we are going to be focusing on that tool today. It is part of standard Jump, and it comes with all licenses of Jump, so you have access to it if you have Jump. I'm going to show a tool. I'll just show it right up front, and then we'll kind of talk about why that tool exists. Maybe kind of wrap our heads around that, and then what I'm going to show at first is some semiconductor data. But if your data is not semiconductor oriented, don't worry about it. Don't tune out. We're then going to go to a completely different data set as a case study, and we'll start to kind of dive deep into lots of the options in the Process History Explorer. So I'm going to start with just a workflow that I've recorded. This is pulling up some data. We could pretend that it's pulling from a database, and it's giving me this tool. And this tool is the Process History Explorer. And it is telling me that when I run my process, this thing called tool, planar tool 8, has the lowest yield. And because Jump is interactive, I can use things like the local data filter to say, well, let me drill down one more step to when we are using planar tool 8, then what's the biggest source of yield issues or the biggest problem? And that's saying that, well, now when we're running planar route number 6 with tool number 8, that's the problem. And what I find is usually within just one or two clicks, you can work your way to you can work your way from I've got a bunch of data to now I need to go to the shop floor and talk to people because I've found a problem. So I'm going to go ahead and reverse this, and don't worry, that was pretty fast. We're gonna kind of walk through this. I want to take a moment to talk about this data structure here and how it can basically how we can reduce some fairly complicated data into a very easy to digest tool. And the tool itself can help us find yield problems. It can help us find stagnation in our processes. It can also help us to see when there are changeover problems that are affecting yields. And really, I'm going to kind of walk you through some data here and understand this. And this would be two different data tables. The Process History Explorer requires two data tables, and these data tables really are set up pretty much exactly how you would pull them from your database. And so it's just a long flat list of different things that I think might identify my product or my batches or my production process, different things that I think I might want to look into, as well as time in and time out. Now, I've added the yield and lot wafer to this just so that this visualization can work, because I want to walk through kind of what's going on with all these 156,000 rows. So if I look at lot wafer 1, it's got 125 different rows in it, and maybe the first layer in this process. And again, if you're used to semiconductor data, this is probably just review. But if you're not, we're going to walk through it really quickly, and then we will switch to a different data set. But anyway, so this is a kind of a complicated process. So visually looking at this data, what happens is each of these wafers that goes through production has a number of layers. And then each of those layers has a number of steps that they go through. And at each of those steps, there's a tool that's being used, and that tool will have a recipe that's used at that tool. And so I can look at, maybe 4 layers of just this one tool. And let's revert the scale here. And so I can see that this starts to get really, really complicated. But what I want to do is I want to find where's the problem, right? So if I look at this data itself, back to the data table, I've got a whole bunch of data that could be about 1.5 billion combinations from just a fairly simple data set. Not this data view, but the actual data set itself. A fairly simple data set gets me into a lot of combinations. I need a tool that I can really distill this down to a relevant portion and that I can do it very quickly. So take a look at a visual, and maybe this will help us to kind of understand this. Now, what I could do if I'm familiar with modeling is I could come to the Analyze menu and I could use the screening platform, and I might be familiar with some of these tools. I'll choose response screening here, and I might say, and again, this would require me to make some changes to the data, which I've added just for the sake of this, but I could say, well, of these 3 things, does anything really affect that response of yield? And I might get an answer to say, yes, one of them does. And so these tools might tell me sort of as an analogy or something, that a few columns in my data are affecting an output. I might want to go ahead and maybe fit a model to those. But that's really not going to work with this data. This data, nor is it going to work with what I'm trying to do. I'm just trying to find the problem. I'm not trying to understand how everything works together. So maybe I might, instead of doing this, try to do something like a partition, and I might look at this and say, well, do any of these things influence that yield? And I can hit the split button, and I could probably get to a problem eventually after splitting a whole bunch of times, but it's just not efficient. What I want instead is I want a tool that tells me, hey, buddy, when you run this production process at these settings, this is a problem. And that tool is the Process History Explorer. So let me just pull it up. And we've seen this already, but this is telling me among all the different things that we asked for, running planar tool number 8 is the issue with yields. And again, I like to use it with the local data filter. And so if I drill down again to planar tool 8, now I have something that I can go look at in production. I can start to dig in and look at the reasons why. Okay, so that being said, I want to switch gears a little bit and take a bit of a deeper dive with this, with some data that might be a little bit more applicable to more of us. And that will be some high volume, high mix factory data. And I've got a script here that's just going to generate some random data, and we can kind of walk our way through it. So while it's generating, basically I can say, we're working at a company, and we're going to call it the Red Triangle Widget Factory. And I'm a process engineer there, and I want to know what is the thing that's going to get us the most bang for our buck. What is the problem that I need to be working on? So again, data structure is kind of important here. So we'll take a second to look at this, and I want to look at the data. So let's imagine that I just pulled this from a database, and again, I've got the batch, my SKU. I made a little formula here to combine the two of those. We'll show why in a little bit, but all these are just things that you would pull directly from a database, right? And here at Red Triangle Widgets, we are an organization that prides itself on lean manufacturing. We're doing made to order, so a customer ordered looks like they made an order with four different products. Each of these products has a raw material or a base component that we do some number of processes to. So maybe it would be uh, assemble, paint, and inspect, or it could be, anything like that, right? Uh, the production scheduling folks have the option among 5 different production lines, so they can schedule these things kind of wherever to balance the load. Uh, the production lines themselves have multiple production cells, and then the the process for each process has a number of steps. Now, in reality, you'd probably have a different number of processes per component and a different number of steps. Since I wrote this as a script, I didn't get super creative, and it's just you get 3 processes and 10 steps. If you were pulling this from a real database, you'd probably have a lot more variation in this data, but not to worry. So that being said, I want to know from this data, I want to know where my opportunities are. I want to know, there's this saying that opportunities are in your waste, and really the data should tell you where that waste is. So we're going to use the Process History Explorer. Now it's in the Analyze menu under Screening, and it's all the way at the bottom. And that's why I mentioned earlier this kind of maybe this undiscovered gem. It's way at the bottom, and when I pull up the Process History Explorer, the menus are a little bit more complicated than most things. Most things only require up to maybe 2 things to be filled in JUMP. This requires probably 3 things or 4 things, even with a timestamp. So essentially, the question comes: which do I put? Do I put things in a process category, or do I put them in a step category? Now, we'll make this journal available afterwards. So I've got some mnemonics here, but essentially, if you want to focus on yields, then you'll put it in the process. If you think that these steps or these fields might relate to yields, we'll put it into the process setting. And if we want to focus on, finding where things are being stagnant in production, then we'll put it into the waiting role. I've got a little graphic right here that might help with that. And this x-axis will make sense in just a moment. So that's a long way to say that depending on the way that I might want to approach the problem, I might fill in the dialog box a little bit differently. And that's kind of unique, but it's really, really useful because you can do a lot with it that way. So if I want to focus on yields, I might put, so my identifier, and then all of the things that I'm thinking might influence yields into this process. I'm going to put step in here because I don't really care. Going back to our example, I'm not worried about optimizing in each production cell. I'm looking at more of the big picture. And then for timestamp, it requires 1, but if I have in and out, I can put both of them in. But this dialog box might look different than if I was focusing on waiting time. We'll come back to this and we'll do both. So we've got plenty of time. So when I run this, the next thing it does is it says, hey, I need to know where the yields are because it's going to automatically build that for us. So I tell JUMP it's in the yields table and it's in the yields column. And that was something, I kind of skipped over that a little bit. I grabbed 2 data tables from my database, one with the yields for each batch and product number or SKU, and then one with all the things that I think might be important or might be influencing yields, right? Okay, so I get this Process History Explorer, and it's just a very small, unassuming report, and it doesn't tell me anything yet, except, yeah, there's a lot of different possibilities here. So this little red arrow sort of dares us to do things with it. And I've got these kind of laid out here for you if you want to look at this later. But to start with, this levels with lowest yield, I think this is the one that's probably going to work the most for you most of the time. And it's really easy. You push the button, and then you get to kind of what we have already seen twice. This is saying that when I run in production, among all those different categories, the base component is the most important category. And I have to go down like 15 or 20 line items until I get to production line being a category for splitting up yields. So base component is the most important. And not only that, base component 15, if I look at the yields here, is yielding 5% lower than the next worst yield. And I've done this before, so I think this tool really needs to use the local data filter. So if I now look at base component and select base component 15, then immediately I see that it's not just base component 15, but it's base component 15 when we are running in production line 1. Now that's interesting because if I look at this production line 1 here, they're yielding at about 66%, but the other production lines are yielding much higher. Another interesting thing about this, I mentioned that our production schedulers have the option to choose which production line to use. So it looks like base component 15 is favored to run in production line 1, but when we run it in the other production lines, maybe as an overflow type thing, it yields much higher. I have enough information right now just from doing this that it's time for me to go to the production floor, to look at tooling, to start talking to people, to look at, why is base component 15 in production line 1 so much worse than when we run it in the other production lines? I love this tool because it just really drills down super fast, and so fast that it's almost unbelievable. So that's probably the 80% rule for using the Process History Explorer is just run it, look at the lowest yield, and then add a local data filter to drill in until you get to the point where you say, okay, I think I have enough information to go to production now and take a look at it. Okay, so that being said, I want to also maybe look at some of the other options. And we'll go with this levels with lowest yield with time filter. And this is going to find stretches in the data where a certain product may have yielded more poorly. Now, it is using that local data filter, so I'm going to go ahead and get rid of that so that we have sort of all the data. But again, you can drill in with it just fine. Once again, this is saying that base component 15 was the culprit, and it's giving us here a production run where the yields were poor. And so maybe things yield just fine for a while and then they stop yielding well. Well, this will find that. And not only that, because it's JMP, you can make any of these reports into a data table, and then the point of this is not Graph Builder today, but you can use tools like the Graph Builder to make some reports, and so we can look at this worst yielding one. So that was base component 15. So that looks like it was a while ago that it had this really bad yields. But if that problem's not solved, it's going to come back and bite us. Likewise, we've got some fairly new low yielding trends that happened fairly recently, maybe as of May or whenever this data was made up. So we can do a lot of really cool things with that. Another really cool thing is to use the stepwise regression. So this is also taking into account yields, and it's saying, well, maybe you could find the biggest offenders that describe the most difference in the yields. And there's some options you can use, but when you hit the button, then it tells you kind of once again, well, here's this base component 15, and it's accounting for 3% of our total difference. I want to show you also the transition analysis. So this would be some people would call this maybe changeovers. So maybe, maybe I've got this question maybe about component 15. I saw in the data that depending on the production line that we used, we got different yields. And so maybe I want to see, are there any changeover issues with any of these production lines? And I'm just going to look at them all. And it gives me a couple of options here to say, well, from a specific column to a specific column, nope. From a specific production line to a specific production line, no issues there. No issues of a specific production line to any other production line, nope. What about from any production line to a specific one? Nothing really to worry about. But when the production line doesn't change over, so there is a bit of a difference here, right? And this isn't huge, but if there was a big difference, we would be able to know. We'd be able to see, wow, production line 1 has tons of problems, or whenever we change over from production line 1 to production line 2, we have a problem. So that really gets me to, out of my chair and into production to start asking questions very quickly. So those are the tools that you can use in the Process History Explorer to understand yields. I'm going to close this now. We can always pull it back up if there are questions. And I want to relaunch it thinking about waiting time. So I'm going to go back to the Process History Explorer, and we'll go Analyze, Screening, Process History Explorer. And this time I'm going to launch it a little bit differently, and I'm going to focus more on waiting time. Where is my product stagnant? And so in this case, I want to look at all of my products, and I want to look at the base component and the process and the production line and the cell, excuse me, not the process, being the step. I do need to keep something in the process. So I'll throw process in there. And my timestamp. And again, I've got an example of this in case you want to rebuild this, no worries. So we can go ahead and run this. And now, again, I have to tell Jump where my yields are. It's going to make that automatic join in the background. I've got my cursor daring me to do things. We've done quite a bit of this already, but I'm going to do this waiting time analysis option now. And this will take, depending on how much data you have, it may take 5 or 10 seconds. It's probably going to take double that because I'm also sharing my screen. There we go. And now I get a number of different lists of waiting time analyses. And one thing that's really cool is I can also look at yields in the same chart. And so maybe I want to do that same trick that I did before of exporting this into a data table and then maybe doing a graph of waiting time versus yield. So I can kind of strategically look at what are the things that I need to be focusing on. So I could look at this product right here, our product number 141. We've only run it twice, but it's yielded way down at 68%. So now I can start asking questions. Is this a new product? Are we waiting? Is it waiting because of a tooling issue? Is it waiting because of a documentation or a paperwork issue? Kind of the same thing with this one. This is yielded just fine, but we've only run it 3 times. I can also maybe focus on just the things that we run really often, and maybe focus on some of our big hitters. This one right here is yielding really poorly. We're running it all the time. Anyway, it's looking at yield as well as waiting time. Really, really nice to compare the two of them. So basically, one other thing I want to show you with the Process History Explorer is what if you wanted to put this into an environment where where you wanted lots of people to look at it and be able to use it, but not all of those people had access to Jump. So if you do have access to Jump Live, you can put those graphs in, but you can also um, put the process history explorer into Jump Live, and imagine this automatically updating by itself. And so maybe a person could, you arrive at work, you pull out your phone, and before you even show up to your desk, you have, again, this is the same data we just looked at, so it's fairly simple. You have diagnosed that, wow, we have a problem in production line 1 with base component 15. So you can show up there immediately and see, hey, I see you have a problem. How can I help? Um, that's really, really powerful to me. So again, maybe in summary, process history explorer, you can find yield problems really, really fast. You can find where things are being stagnant, where your production is being stagnant. You can also find problems changing over from one item to the next, basically any type of changeover, and you can do it all pretty quickly. So, what questions still exist? What questions do you have?
So a couple people asked questions about the two different data tables, but could you
Yeah,
just speak to that for a few minutes? Because that question came up more than once.
if I understand correctly, the reason why we want two tables is really just a convenience factor. This is probably the way that you would get the data directly from the database. And so if I were in Jump querying my database, if I were querying my database, I would grab these columns from my database. And this is basically exactly how they would come in. Step 2 might be to make this as a formula column to concatenate them, but I don't need to grab the yields into this one because that would require me doing some sort of a join or an update. Whereas my second database query would be, I'm just going to ask for batch and SKU and yield, and the database will spit that out for me. Again, I'm probably going to make this concatenation column, maybe, but maybe I wouldn't have to. So maybe if I can put it very shortly, the reason why we have two data tables is because that's how you're most likely to get the information from the database and to basically save that extra step of matching them. Yes,
Okay.
you can have any column that you want here. You just need to tell Jump, um, again, kind of what we did earlier, screening, process history explorer. Goal is to, I'm assuming you'd want to minimize your standard deviation. I can't think of a reason why you'd want to maximize it, but assuming you'd want to minimize it. And then once you hit OK, that next pop up that says, hey, show me where yields are. Well, you would point it to your standard deviation column, not yields.